Alright, Assalamu alaikum. This is Talha bin Nadeem, and I'm here with another video tutorial for the course of internal combustion engine. In the last video tutorial, we solved some numerical problems of the carburetor, and now today we will start off with a new topic, and it is of mechanical injection systems. So as you guys are already familiar with the concept of spark ignition and compression ignition engines, you guys must have studied in the beginning chapters of this course. The basic difference between the SI engine and CI engine is that in spark ignition engine, what we do is we basically make the air fuel mixture, and that air fuel mixture is being sent to the combustion chamber for combustion when the spark is ignited. But if we are talking about a compression ignition engine, in compression ignition or CI engines, what happens is that we only compresses air in the combustion chamber, and then the fuel is injected at the end of the compression stroke. And when that fuel is injected in the combustion chamber, and since the temperature of air inside the combustion chamber is already quite high, it is quite high enough that it exceeds the self-ignition temperature of the fuel, and as a result the fuel which is being injected into the combustion chamber will get enough amount of energy from the surrounding hot air and will self-ignite itself, thus resulting in the combustion. Now the main difference between SI engine and CI engine which occurs is that since the air fuel mixture is going in spark ignition engine, so for the preparation of that spark ignition engine, the preparation of this spark ignition for the preparation of this air fuel mixture for this spark ignition engine is achieved by using a carburetor, which we studied in the earlier classes, in the previous lectures. So but when we are talking about a compression ignition engine, we have only we have only entered air in the compression in the suction stroke, and after the compression of this air, the fuel is injected separately, means there will be no air with the fuel when it is being injected. So the fuel is injected after the end of or you can say at the end of compression stroke, and it will gain the heat from the surrounding hot air and it will self-ignite itself. So for the injection of this fuel, what we require is what sort of a system which we uses in our IC engine is called injection system. Or you can more specifically say we will study about the mechanical injection systems. The modern cars are basically using electronic fuel injection system, which is a separate thing, but the concept will remain same, which we will study in this topic. So now starting off with the basic introduction, The fuel injection system is, as I mentioned earlier, one of the most important components for the CI engines. And it is because of the fact that the fuel is being injected by this system. We are not preparing the air fuel mixture and not sending that air fuel mixture into the combustion chamber. We are only sending air in the combustion chamber, then fuel is being sent separately at the end of compression stroke, and that is what the mechanical injection system is doing. So the engine performance is significantly dependent on how effective your fuel injection system operates. Means that the speed and load is varying of your IC engine at when you are operating your car on a city road. Speed and loads are varying, and in order to supply the desired amount of fuel as per the load requirements, this is how effective your injection system should be. So injection system is one of the most vital component, and it should be very effective as well in order to overcome the speed and load requirements. So the injection system has to perform the important duty of not only initiating but also of controlling the combustion process as well, because the fuel is not injected instantaneously. It will start spraying the fuel, and it will continue spraying the fuel for quite some duration of a time, depending upon the engine speed and load. So it is not only initiating or injecting the fuel, but it is also controlling the amount of a fuel which is required by your IC engine for combustion. So it is not only initiating, but it is also controlling the combustion process. So I hope it is clear now. Now moving forward, as I mentioned earlier, that in the SI engines we are basically entering air fuel mixture in the combustion chamber, and the preparation of this air fuel mixture is being done inside the carburetor. But in CI engines, since we are not sending the air fuel mixture in the combustion chamber, therefore the requirement of the carburetor in CI engine is being eliminated, and instead of having a carburetor in CI engines, we would be having a mechanical injection system. And that mechanical injection system, the purpose of this mechanical injection system is not to prepare the air fuel mixture, rather it will be only spraying the desired amount of air at the end of a compression stroke in each cylinders of the IC engine. So the purpose of a carburation and fuel injection is the preparation of combustible charge. The purpose of the both components are same. The carburetors are used in SI engine, and mechanical injection system are used in CI engine. So the purpose of these systems are same, that they have to prepare the combustible mixture, but there are some differences. And what are those differences? We will go through the brief details of it. As I was explaining the topics of a carburetor in the earlier classes, I explained that the air is coming from the atmosphere and then going into the venturi section, at where where the speed of the air is being increased, because it's a converging diverging nozzle section. The speed will increase until the air reaches the venturi throat. So in the carburetors, air speed is greater than the fuel speed at fuel nozzle, and because of this phenomena, air is also atomizing the fuel as well. It is not only taking the fuel from the float chamber, but it is also atomizing the fuel. On the other hand, in fuel injection system, we have only compressed air inside the combustion chamber, and fuel is being injected separately at the end of a compression stroke. Since the piston at the end of a compression stroke is already at the top dead center or nearly reaching the top dead center, so the air particles are quite close to each other, since we have only the minimum volume at that when the piston is reached to the top dead center. So when the fuel is injected at that duration, when the piston is almost at top dead center, the speed of the fuel should be very much greater, so that it can penetrate across the air molecules, and it is being sprayed throughout the combustion chamber, throughout the entire volume which is available at that time. So I hope it is clear now. So the first difference is basically in carburation, the air speed was high and it was taking the fuel from the float chamber by producing the venturi effect inside the venturi throat, at the venturi throat, and it was not only taking the fuel from the float chamber, but it was also atomizing the fuel. But in the fuel injection, the fuel speed is higher. Fuel speed is greater than the air speed. So that is the main difference, and because of this fact, since the fuel speed is higher, fuel is being atomized. You can take this example by all of you guys must have ironed your clothes, and when you are pressing your clothes, you have a spray bottle in your homes, which you basically spray the water by using it. So when you have a nozzle, and when you tightly press it, you will have a larger spray. So when you have a very small area and you are increasing the pressure and the fluid is coming outward, not only it is coming outward, but it is also being atomized. And similarly, because in the fuel injector system, it is just like that. The fuel is coming out of this injectors, and since the fuel speed is quite high, because of this higher speed, the fuel, and it is since it is also being dispersed in the throughout the combustion chamber, it will get atomized. The fuel was in the carburation, the fuel was atomizing because the air speed is greater, but in the fuel injector, fuel is atomizing since the fuel speed is greater. This is the main difference between the carburetors and fuel injection systems. Now coming towards the second difference, the amount of a fuel drawn into the engine depends upon the air velocity in the venturi. So I have also explained this part in the previous topic, that the greater the air velocity at the venturi throat, the more amount of fuel would be taken in from the float chamber. And how the velocity can be greater? Velocity will be greater when there are more pressure drop between the 2 points which I have shown in the figures in the last classes, in the last video tutorials, from that section 1 to section 2. When the pressure difference across these points are higher, the velocity at the venturi throat would be also be high, because the air is gaining the speed, it is gaining the kinetic energy at the expense of the pressure drop. So the amount of a fuel is basically dependent on how great the air velocity at the venturi throat is. That is how you will control the amount of a fuel which is entering into the combustion chamber along with the air. On the other hand, in fuel injection system, the amount of a fuel delivered into the air stream is controlled by a pump, and these pumps are being used to inject, to pressurize the fuel, and not only it will pressurize the fuel, but it will also inject the fuel into the combustion chamber. So what is the second difference between the carburetors and the fuel injection system? The second difference is the amount of a fuel in carburetors. The amount of a fuel is dependent upon the air velocity at the venturi throat, but in fuel injectors, the amount of a fuel which has to be delivered into the cylinders, into the combustion chamber, is dependent on the pumps, on the fuel pumps. There can be a single pump, and there can be a multiple pumps as well, depending upon the arrangement of a fuel injection system. I will explain that part in the later, in maybe in this class or maybe in the later class. So these are the main differences between the carburetors and fuel injector systems. Now moving forward, now we are coming towards the functional requirements of the injection systems. First one is the accurate metering. Of the fuel. What do we mean by that? It simply means that since the IC engine is operating on different speed and different loads, and thus the fuel requirement is also changing, or as the speed or load changes, so your fuel injector has to overcome all of these conditions. For example, when you are operating your IC engine on higher loads, you will require a rich air fuel mixture, and your injection system has to provide that much amount of a fuel to make that air fuel mixture rich. And when you are operating under a normal conditions, you require lean air fuel mixture, you require fuel economy. Fuel economy is desirable, and to overcome such operations, your your injection system would be providing a lesser amount of a fuel. So fuel metering is being controlled by the injection system, that how much amount of a fuel would be fuel should be injected per cycle. And this is very critical, due to the fact that we are only entering very small amount of fuel in the combustion chamber for combustion. So since the very small amount of fuels are being controlled, that is why metering is very important, and it should be quite accurate as well. This is very important phenomena. So the question is, what will happen if there are some metering errors? These metering errors may cause some drastic variations in the desired output. which can ultimately cause failure to the IC engine, or may lodge some um, um, it misfiring in the IC engine, which will not only be a wastage of a fuel, but it can also damage your IC engine as well. The quantity, and since the fuel desired amount of a fuel is not being injected, maybe if more amount of a fuel is being injected, there can be a result of a improper combustion, and may result in the uh, it may also result in the production of carbon monoxides and some other toxic gases as well, which are harmful for the from the environmental point of view as well. So moving towards the next function, the timely injection of the fuel. Now this function is also very important. Means that when the piston is reaching the top dead center, usually what happens is, before reaching the top dead center, the fuel injection starts, and this timing of the fuel injection is very important. It is important due to the fact that if there is some mistiming in the fuel injection, it may result in improper combustions, and it can cause the decrease in the fuel economy, and not only in the decrease in fuel economy, but it will also produce some of the undesirable waste gases as well. So metering is very important, and that timely injection of the fuel, they are some of most important functions of the injection system, which your injection system has to perform. So moving towards the next function, and that is of the controlling the rate of injection. Because the proper heat patterns are desired, or proper combustions are desirable, that's why the control of a rate injection is also very important function. And not only that, the another thing which is very important, and which should be considerable as well, that as I was explaining, that in carburetors here is not only taking the fuel from the float chamber, but it is also atomizing it, so that the purpose of atomization is being achieved by the mechanical injection system as well. So the next function is also of proper atomization. It is desirable to ensure that the homogeneous mixture is being prepared after the fuel is being injected inside the combustion chamber. So what are the important functions? Number 1, accurate metering. Timely injection of fuel. Number 3, controlling the rate of injection. Number 4, proper atomization of fuel. Okay, now moving forward. Now another important function is of proper spray pattern. This phenomena can be understand if I simply draw you a diagram. For example, these are two combustion chambers, and this is your fuel injectors. In SI engines we have spark plugs at this position, and these spark plugs are being replaced by fuel injectors in CI engine. One is this spray pattern and other one is this spray pattern. So the second spray pattern is basically covering a larger area, and thus it will result in making a more homogeneous mixture, a mixture which is more close to homogeneous, you can say, because both of them would not be making a proper homogeneous mixture since the fuel is injected afterwards. But the second configuration would be making a mixture which is more close to being a homogeneous mixture. So that is also the function of a injection system. Similarly, it also has to ensure the uniform distribution of fuel droplets throughout the combustion chamber, and it is being ensured by having a proper spray pattern. Now moving forward, for example, when we have a multi-cylinder engine, your fuel injection system would not only have to deal with the above mentioned functions. Another important thing is that your injection system has to provide the same amount of a fuel to each of the cylinders. Okay, your injection system has to supply equal amount of a fuel, equal quantity of fuel to each of the cylinder. So now moving towards the last function, and that is there should be no lag. What do we mean by there should be no lag? It means that the injection of the fuel should start and end at that specific point when it should be happening. Means there should be no dribbling of the fuel particles after the combustion process. No new fuel. It means that simply there should be no fuel particles are being injected after the combustion process. You can simply understand the dribbling phenomena that, for example, you in your homes, when you have if you must have seen that if there is some old taps, even when you are closing that tap, some amount of a water is dribbling from that tap. This phenomena is basically called dribbling. So your injection system has to ensure that after the desired amount of a fuel which has been injected into the combustion chamber, there should not be any more particles of a fuel which should be injected in the form of a dribbling. So your injection system has to ensure that. So these are some of the functions of the injection system, which mechanical injection system, which needs to be understood. And now moving forward, we have some classifications of injection system. As I mentioned earlier, that a fuel injection system is required to not only to inject, but it also atomizes the fuel into the cylinders of CI engine. It is not only injecting the fuel, but it is also atomizing the fuel. I have explained this part earlier. So for production, for producing the required pressure for atomization, the fuel is either mechanically or by air. Air means is being pressurized. means when we are injecting the fuel and we are atomizing the fuel, you basically require this fuel at high pressure. And how are we going to pressurize it? So either we will do it by compressing some air, or we will do it by some mechanical means, or you can say by using some pumps. So on the basis of this phenomena, we can classify the injection systems into two categories. The first one is the air injection system, and the second one is solid injection system. Air injection systems are those injection systems in which we are basically using air. We are compressing the air, and that compressed air is being used to pressurize the fuel. And the solid injection systems are those systems in which fuel pumps, in which the high pressure pumps are being used to pressurize the fuel for injection. We will study the solid injection systems in details. Air injection systems are almost obsolete and they are not being used, and the reason for that is, for compressing the air we require some heavy multi-stage compressors, and these compressors also require some electricity to operate. Therefore, because of these large compressors, the size of the engine has drastically increased. That's why these air injection systems are obsolete and solid injection systems are most commonly used. We will just go through the brief introduction of the air injection system before moving towards the solid injection systems. In this system, fuel is forced into cylinder by means of a compressed air. I explained that part, that we are compressing the air and that compressed air is being used to pressurize the fuel. These systems gives some advantages. The first one is it gives the better mixing of a fuel with air. Since the compressed air is being used, so the entire volume of the fuel which would be injected inside the combustion chamber would be at that pressure, and thus it would be giving a more effective mixing of the fuel with the air. Second one is they give the higher mean effective pressures. Third one, that it has and it is also a very important advantage, that it has the ability to utilize high viscosity fluids, high viscosity fuels. These high viscosity fuels are called low grade fuels, means they are not good for the IC engines, but they can be utilized, they are being used, they can be used by using when we have air injection system. But there are some disadvantages of the system as well, and the most important and the very important disadvantage of using these air injection system is that they require bulky multi-stage compressors. These bulky multi-stage compressors will increase the size of this of your IC engine. Therefore, these injection systems are almost obsolete now. Now moving towards the solid injection system, as I explained earlier, that in solid injection system we are not using air for pressurizing the fuel. Therefore, these systems are sometimes also referred as airless mechanical injection systems. In these systems, the fuel is directly injected into the combustion chamber, and this fuel is being pressurized by using some high pressure pumps. and we are not using air for the pressurizing the fuel. So I hope the difference between the solid and air injection systems are quite clear. These solid injection systems can be classified into 4 categories. The first one is individual pump and nozzle systems. Second is unit injector systems. Third is distributor systems. And the third is common rail system, and the fourth one is distributor system. I will explain these four arrangements, configurations later in the class, or maybe in the next video tutorial. But before moving towards these 4 configurations, I will briefly go through the main components of the injection system, of the mechanical injection system. I explained that part earlier, that we would not be studying the air injection system, since they are being obsolete because of their bulky sizes. So first important component is the fuel tank, where your fuel is being stored. Then there is a fuel feed pump, which is taking that fuel from the main fuel tank to the fuel injection system. And this fuel feed pump is increasing the pressure of the fuel, but these pumps are low pressure pump. They are not increasing the pressure that much. And when this fuel from the fuel feed pump reaches the injection system, there we have the another injection pump, which will increase the pressure as well, and these pumps are high pressure pumps. So we have 2 pumps here. Usually we will have 2 pumps in a mechanical injection system. First one is fuel feed pump. They are called low pressure pumps, and the purpose of these pumps is to take the fuel from the main tank into the injection system. Then we have injection pumps. The purpose of these injection pumps is to increase the pressure, and not only to increase the pressure, but it also provides the accurate, it also meters the accurate amount of a fuel which needs to be injected into the combustion chamber. Then we have another component which is called governor. As I mentioned earlier, that fuel injection pumps would be metering the amount of the fuel. The question is, how would they be metering it? And the answer to that is, governor is that equipment, that component of your injection system, which is basically allowing the injection pump to regulate the amount of a fuel, okay, depending upon the load variations. I will explain these fuel feed pump, injection pump and governors in details in the next couple of video lectures. So you don't have to worry about how would they be operating. I will explain these parts in the later classes. So far we have studied the 4 main components. First one is the fuel tank, and we studied that fuel feed pump will take this fuel from fuel tank into the injection system, where we have injection pump. This injection pump is not only pressurizing the fuel, but it is also metering it. And how it is metering it? Governor is basically responsible, which is basically controlling it is basically controlling the stroke length. I was not trying to use that word, that what is stroke length, because I will explain this part in when I would be explaining these components. So governor is basically controlling that how much amount of a fuel the injection pump would be injecting into the combustion chambers. Then another component is of injector. This is your nozzle section. We will study this part as well, this component in details as well. So the purpose of injector is to take the fuel from the injection pump and then distribute it into the combustion chamber, and not only distribute it, but also it will be atomizing the fuel into the fine droplets. The last main component is of the fuel filters. These fuel filters are placed before the injection systems. These fuel filters are being placed before the injection systems, and what they would be doing is they would be removing the dust and some abrasive particles before it is being entered into the pump and injector, and thus resulting in reducing the wear and tear of the mechanical injection of the components in the mechanical injection system. So we have studied so far the 6 components. Now we are moving towards the schematic of this mechanical injection system. This is the typical schematic of the fuel feed system for the CI engine. Here you can see this was our first component, fuel tank, and this plunger feed pump, this is our feed pump. This is taking the fuel from the feed tank in, and you can see that since the fuel is coming from here, it is passing through the filter. And what is the purpose of these filters? This coarse filter is basically removing some of the high those particles which have greater sizes, that's so that it may not damage the plunger in this feed pump. Then this plunger feed pump will have pressurized the fuel, but it has not significantly pressurized it. Before going into the fuel pump, it will go through the fine filter as well, and from here, this after passing through this fine filter, it will go to the fuel pump. So now we can clearly see that we have some filters to remove the debris and some abrasive particles which are present in the fuel. We have a fuel tank. Plunger feed pump is pressurizing it, but it is not pressurizing it that much. And after this plunger feed pump, fuel has entered into the fuel pump. This is our main high pressure pump. High pressure pump. This is a low pressure pump. And from this fuel pump, this fuel is being supplied to the injector, and then being sprayed inside your combustion chamber. And if there is some excessive fuel, it is being sent back to fine filter, and then it can be reused again. And if there is some increase in the pressure, then here you can see there is a pressure relief valve. It will be opened and that excessive fuel would be sent back at this point. So this is how the main components, this is how the main components of the mechanical injection systems are working. So you can see that we have I have explained 6 components, and I am now marking these 6 components. This was the first one, fuel tank, then the feed pump, then we had fuel pump. Governor is not shown in this diagram, but it would be controlling the fuel pump. So I'm not as it is not being shown here, so I'm not mentioning it, but it would be here, it would be present in this place and would be controlling this fuel pump, that how much amount of a fuel it should be injecting. So this is your this will be your fifth component, injectors, and these filters are your 6th component. So I hope I have tried my best to explain the injection system, the main components, and the categories as well. Now moving towards the working of this mechanical injection system. Fuel from the fuel tank is first entered to the coarse filter, from which it is being drawn into the plunger feed pump. Feed pump is basically taking the fuel from the fuel tank, and it is being passed through coarse filters, where the pressure is raised, but very slightly. I have explained this part as well. Now this fuel will go through the fine filter, where dust and dirt particles are also removed, and from that fine filter now the fuel will enter into this will not be fuel feed pump, you can simply say it is a fuel pump. Okay, the second pump, which was a high pressure pump, it from fine filters it is going to that fuel pump, which was a high pressure pump. Now in this high pressure pump, the fuel will be pressurized to about something 200 bars, and then it is being injected into the engine cylinder by means of a injector. If there are any spillover in the injectors, they would be returned back to fine filters, as I explained in this, that if there are any spillovers, they would be sent back to the fine filter. A pressure relief valve is also provided, and it is it is for the safety of a system. You must have also seen this pressure release valve in the domestic geysers in your home as well. You can see that there is a pressure relief valve. If there is a increase in pressure due to some any abnormality, then there is a pressure relief valve which will be opened, and that excessive pressure would be released from this pressure relief valve. It is a safety instrument for your device. So now I hope these concepts are clear. In the next video tutorial, as I explained, that we will start I will explain these four configuration. I will start from these four configuration. In today's class we studied the basic concepts of the fuel injection system, and what are the operations and what are the operation and the functions of this fuel injection system. Then we studied the difference between the carburetors and fuel injectors. Then we studied some of the functional requirements of the injection system. These are the requirements which injection system would be fulfilling. Then we discussed the classifications of injection system, and I explained that air injection systems are being obsolete and only solid injection systems are most commonly being used. Then we briefly discussed the air injection system. Before moving towards the solid injection system, I explained that how these solid injection systems are operating and why they are being called airless mechanical system. Then I also told you the four different types of a configuration which are being commonly used in solid injection system, but I didn't explain the details of these four configuration. And I mentioned that I will explain this part later in this video or maybe in the next video. So I will explain these four configurations in the next video. Then we studied the main components of the mechanical injection system, and we studied this schematic, and we highlighted the components which we studied in the previous slide. And after that we also studied the working of this mechanical injection system. I hope this is clear to you, and we will continue the details of this mechanical injection system in the next video tutorial. In case you guys have any questions regarding this topic, just note down these questions and you can ask me those questions in the live session, and you can also ask me these questions by using the WhatsApp group or the Google Classroom as well. There is no problem about it. Okay, see you in the next video. Allah Hafiz.